Welcome everybody. Now this is the I think 11th week. Yeah, 11th week, and we have one more question from the online lecture. This one. Yeah, we have an fx is equal to 3x squared and hx is equal to 4x and g of x is equal to 5x cubed. And the question is delta f of x plus g of x minus h of x derivative of x. Yeah, delta fx gx minus h of x over delta x. This is a question. So, we have to write the equations here. 3x squared, 5x cubed minus 4x. And to find the derivative of this function, this total function, we have to find each part's derivatives. So, in fact, it is easy to find, but I have to show the steps here. And minus delta over delta x, 4x. These are the functions. Yeah. And so we know that the derivative of 3x squared is 3 multiplied by 2x and 3 x squared. We subtract by 1 x cubed power 3 and 4. You know that we have 1 here and x to the 1 minus 1. So 6x and 15x squared and minus 4 here. And this is the answer of the question. Now we continue with the subjects. Which one? Yeah, by this one. Our subject is finding horizontal tangents. Let's say as an example also, finding horizontal tangents. The question is, does the curve y is equal to x to the power 4 minus 2x squared plus 2 have any horizontal tangents? If so, where are they? If so, where? The solution for that question is the horizontal tangents, of course, if any, occur where the slope, we can find the slope by derivative of the y function, we have fx, dy over dx, I mean, is 0. If we find the derivative and we make it as equals 0, so we find the solution as the slope and the horizontal tangents occur there. So dy over dx is equal to, from here, 4x cubed minus 4x, and we have to equal this one to 0. 4x cubed minus 4x is equal to 0. So let's make parentheses by 4x and x squared minus 1, and here we have 4x is equal to 0 and x squared minus 1 is equal to 0. Here we have x is equal to 0, and here we have x minus 1, x plus 1. So here x is equal to 1 and x is equal to minus 1. We have three tangents, the point of tangents, I mean. That is, if we have, we can write it as like that also. 0, 1, and minus 1. Don't forget these r's, these points. Yeah, the curve, yeah, here, the curve, you know, has horizontal tangents. We find at x is equal to 0, 1, and minus 1. So corresponding points are, we have, the function is like that. Fx is equal to x to the 4 minus 2x squared plus 2. So corresponding points, f0 is equal to 0 minus 0 plus 2. So it is 0 abscess and 2 ordinate, we know, like that. And for f1, we have 1 to the 4, 2, 1 square plus 2 is equal to 1. So it is 1 and ordinate 1 also. And for minus 1, f of minus 1, minus 1 to the 4, power 4, minus 2, minus 1 to the power 2 plus 2, it's again 1. So minus 1 and 1. So these are the tangent points, tangent line points. That is, we can draw it like that. Maybe something like that. And here, here is minus 1 and 1. And here is 1 and 1. Here's 1 and 1 point. And this is minus 1, 1 point. And here is 0, 2 point. These are tangents. Yeah, tangent lines are also here. We can also find the tangent lines here, but this is not our subject now. You know that if you find the slope and you find the points, if you know the points and the tangents, this one is the line equations, that is x minus x0. If you know the points, such as, let's say our point is this one, and you put 1 here and minus 1 here for x0 and 1 for y0, and you can find the m by finding f prime, this is 4x cubed minus 2x, 4x, and if you put minus 1 here, minus 1 for here, so you can find the m also here. So you can find the slope, and you can find finally the line equation by this one. So next one, we have products and quotients. Products and quotients. Products and quotients. Now, fifth rule, that is rule 5. Derivative product rule. Product rule. derivative product rule. So if we want to give a definition, if u and v are differentiable at x, so we can write like that is their product u multiplied v, and that means if u and v are differentiable at x, their product u is also differentiable at x, and we can write it by like that: d over dx uv is equal to u multiplied by dv over dx, that is derivative of v with respect to x, and v multiplied by du over dx, that is derivative of u with respect to x, v multiplied with v. And this is the formulation for products. So for this one, also we can write, I think, something more for this one, but can I find it? Oh, whatever. Okay, let's give an example and then I will say it. Okay. Yeah. Example for this one: y is equal to 1 over x squared plus 1 over x. Solution for that, I think I give something. Yeah. So on the 10th week, I think I give this one 1 over x is a derivative. So we can either do that, or I can also make you remember for this one. Here we have u is equal to 1 over x, and v is equal to x squared plus 1 over x. So if you want to find the derivative of y, we have to find the u prime, you mean derivative of u, and multiplied by v, and u multiplied by derivative of v with respect to x. So then we have to find u prime and v prime. For u prime, we know that x 1 over x means x to the minus 1. We also do it as a subject, but not now. In this lecture also, we can do this. And you know that u is this one, and u prime is equal to minus 1 x and subtract 1 to the power. So it equals this one, that is x squared. So u prime is this one, and v prime, v is equal to x squared plus, again, x to the minus 1. So v prime is equal to 2x minus 1 over x squared. They are same. So finally, if you want to write y prime, that is delta y over delta x, or the derivative of y with respect to x, is equal to u prime is x to the power minus 2, and v is equal to x squared plus 1 over x, and u is 1 over x from here, and v prime is 2x minus 1 over x squared. Yeah, finally we know that this is minus 1 minus 1 over x cubed plus 2 minus 1 over x cubed. So finally, from here and here, 2 minus 1 is 1, and minus 2 over x cubed. This is the result of the solution. And next one. From here, we understand that this is the derivative of the function of the formulation also. They are same. that is product rule d over dx of fx multiplied by gx is equal to f prime x multiplied by gx and plus fx multiplied by g prime x. We have to know this one. And let's give another example. Let y is equal to u multiplied by v be the product of the functions u and v. Find y prime at the point 2 if we have u2 is equal to 3, u prime 2 is equal to -4, v2 is equal to 1, and v prime 2 is equal to 2. So if you want to find the y prime of x, so we have to write that u prime multiplied by v and ux multiplied with v prime x. So if you want to write y prime 2, so you put all 2 here, 2, 2, and 2 here also, and u prime 2, from here we know that it is 3, and v2 is 1, and here is plus, by the way, here is plus, and plus u prime first, and this is 4 first, -4. Here's -4. And 1 is true, yeah. u2 is 3, and finally v prime 2 is equal to 2. So -4 plus 6, and the result is 2. Yeah, this is the answer. And another question. Find the derivative of y is equal to x squared plus 1 and x cubed plus 3. Now we have two ways for this one. First way, maybe like that. We can easily multiply two of this fx, and maybe let's say this is fx and this is gx, and so we can multiply fx and gx and then find the derivative. So y is equal to, we can multiply y like that, x to the power 5 and 3x squared, and here, this is x cubed plus 3. So finally we have y prime is equal to 5 x to the power 4 and 6x and 3x squared, and the derivative of constant value 3 is 0. So this is first way. And if you want to find any value, this derivative of this y prime at any value, let's say for 1, we can find, this is another example, of course, find the derivative at 1, such as like that. So we find y prime 1, and we put this one, and 3, 1 to the power 2, and 1 square, 5, 6, and 3, 11, 14. Yeah, maybe like that. For first question, this question example, and second way, we can use the product rule or multiplication rule, whatever. Y prime is equal to, find the fx prime, this is derivative of fx with respect to x, 2x, and multiply it with gx, and then plus derivative of gx with respect to x, this is 3x squared, and multiply it with fx. So finally this is 2x to the power 4 plus 6 x plus multiplied by these things and 3x to the power 4 and 3x squared. So finally, and this is, these are 5x to the power 4 and 6x plus, yeah, this one, they are same. This answer and this answer are same. So first way and second way are same, and we can do it like that. Now we have quotient rule, I mean division rule, quotient rule, division rule. Now we have rule 6. Derivative of quotient rule. This means division. D over dx. We have u and v, let's say, again, u and v. We have to find like that, multiplied v by derivative of u with respect to x, minus u and multiplied with derivative of v with respect to x, and divided by v squared. May put the equation here. This equals this one. There's nothing here, by the way. Yeah, this is the formula. So if you want to write as fx and gx, g of x, this is f prime x multiplied by gx minus fx g prime x over, denominators square, gx square. So we have to remember this formula also, and so we can do the examples like that by using this formula. Here we have example, and y is equal to t squared minus 1 or t squared plus 1. It says find y prime, that is delta y over delta t, that is derivative of y, derivative of y with respect to t. Yeah. So we know the formula, that is, let's find the numerators. Here is numerator and here is denominator. First, find the numerator's derivative, that is t squared minus 1's derivative, and multiply it with t squared plus 1 denominator, and minus, put the numerator same first, this is fx, and find the derivative of denominator and divide it by denominator's square. Yeah. And if you want to find the derivative of t squared minus 1, this is 2t, t squared plus 1 minus, we put the same t squared minus 1 and find the derivative of t squared plus 1, it is 2t. And we have the same things at t squared plus 1 square as like that for the denominator. And finally multiplied with here, these things. So 2t cubed plus 2t minus 2t cubed plus 2t. Yeah, it's true. T squared plus 1 square. And finally, we eliminate these two things. They are same, and plus and minus sign. And 4t here, or t squared plus 1 squared. This is the answer for that question. If there is a question like that, find the tangent or find the slope of this function for or at t is equal to maybe 1 for 1. So if it is asked for like that, for that question, we have to put 1, this f prime, this f prime. So we can find like that, 1 square plus 1 square, like that, 4 over 2 square, and it is 1. Yeah, it is easy for the slope and the tangent questions also. And now we have another rule. Which rule? Rule 7. Rule 7. Negative integer powers of x. Let's say if n is a negative integer and x is different from 0, then d over dx, x to the power n, is equal to n multiplied with x to the n minus 1. This is the same for the rule 2. This is the same as rule 2. So only we have a negative integer as n. So let's do an example. D over dx, 1 over x. I mean we have to solve it in this lecture. I said it before. You know, we can think 1 over x, x to the minus 1. So here, you know, we are going to put this minus 1 on the left, and we subtract minus 1 to the power of x. So finally, minus 1 x to the power minus 2. That is minus 1 over x to the power 2. Because of this minus sign, we put x to the denominator. Okay. Another question. We have d over dx. Also, we can write d over dx or delta over delta x. These are same. D over dx, delta x, whatever. 4 over x cubed. Yeah, this is the question. Find this one. First of all, we write 4 here, and we have to find x to the minus 3. So for the derivative, we put this minus 3 on the left, multiplying like that, and say abstract it by 1. And finally, minus 12, x to the minus 4, that is minus 12 over x to the 4. Yeah, because of this minus sign, we put the x to the denominator. And another question like the tangent ones. What is that? Find the equation. Okay, maybe we can do it on the online lecture, I think. So this is not important thing for here. That's all for today. So let's see you on the online lecture.